The near future of space mining is very interesting. There is a real possibility that we will start space mining within this decade. So in this video, I want to talk about it and hopefully inspire you to get interested in this industry. With that said, let's get on to the first part of this video, which is
the promise of space mining.
Out there in space, there is an abundance of valuable resources like platinum, gold, and rare earth metals, which we will need if we want to keep building new technologies. This is why, in my opinion, space mining is absolutely necessary. As I'm sure that you are aware, we're running out of resources on Earth. At the rate we are producing nickel, we will run out by the year 2130. Nickel is a key metal for electric cars, planes, and other technologies we will invent. This is simply because it's a key ingredient for battery technology. Now, 2130 may seem like a long time away, but considering we're producing more and more EVs every single year, we might run out long before that. And that's just one example. Another resource that we don't have much on Earth is helium-3, which is emitted by the sun through radiation, and is the ideal substance for nuclear fusion, which would provide us with unlimited energy. You might be wondering, if it's emitted by the sun, why don't we have much? Well, due to the Earth's magnetism and thick atmosphere, a lot of the sun's radiation is blocked. In fact, most of it. That's the reason why we can survive. And so we have very little of helium-3 on Earth. Luckily for us though, a very close neighbor of us has an abundance of helium-3, which is the moon, since the moon isn't protected from radiation. This is why there are many companies and universities alike doing research and planning missions to the moon to hopefully start mining for helium-3. And this is not to mention the various other worlds we can mine. Imagine if we could gather the diamond rain that is believed to fall on the gas giants. Really, the future of this industry is limitless and exciting. Speaking of the industry, it's important to remember that this will create hundreds of thousands of well-paying jobs as well as brand new businesses, leading to massive economic growth. From assembling the mining robots to scouting the solar system for new places to mine, people will play a big part of the process, and I very highly doubt that space mining will be solely a government activity. In fact, as the space infrastructure builds up, such as affordable ways to get to space and off-world human bases, there may even be small businesses that are able to start that specialize in space mining. I guess we'll just have to see. So, it all sounds cool, but why haven't we done it yet? Well, the simple answer is that we don't really have the technology to make space mining economically viable. At the end of the day, we do live in a capitalist economy, so if it isn't profitable, we just won't do it. However, if we do solve the economical and technological challenges, we will be there quicker than you realize.
The technological challenges.
Currently, there are 4 major technological challenges that we have to face before we become a space mining economy. One of the major ones is the extraction techniques. This is simply how we're going to suck out all the materials and minerals out of the source we're trying to exploit. This might sound simple, but you have to bear in mind there are different types of celestial bodies. For example, if it's an asteroid, we need to take into account the low gravitational pull between the spacecraft and the asteroid, as well as the relative small size of it. The reason why the size matters is because if we drill or hammer the asteroid in the wrong place or with too much force, it will simply break apart. To solve this, one method that has been proposed is to use super bright light provided by the sun and focusing it on a specific point. This would mostly be used to extract water and has already been proven to work on Earth. But of course, there are still tests that have to be done to see if it's practical in space. If this was to be developed into a mature technology, it could be a crucial part of the space mining infrastructure, as water is one of the main propellants for spacecraft. On planets, however, or moons, we will have a much easier time for the most part. For one, it's going to be easy to land on, since there is substantial gravity and enough surface area to have a flat surface, again, making it easier to land. Then, due to the gravity, the mining facilities on, say, Mars may resemble the ones on Earth. Of course, with some iterations to take into account the Martian environment, as well as what we actually want to extract on Mars. But still, there will probably be a human presence in these mining facilities, since communication between Earth and, say, Mars will be very difficult and too slow to respond to an emergency. However, autonomous robots will be a big part of these factories. In fact, it is one of the technological challenges that we have to deal with. Luckily for us, we're already investing a lot of money into developing autonomous robots. Not necessarily for the space mining industry, but to do stuff on Earth like manufacturing or hoovering. Space mining operations will rely heavily on robots, since for the most part, space is completely inhospitable to humans. We don't really want to be sending people on an 18-year-old journey journey to Neptune just so they can mine some rocks. These types of missions will have to be done by robots. These robots will have to be advanced and autonomous, capable of performing difficult tasks like navigating terrain, excavating, and processing the material, as well as bringing these materials back, most likely to Earth or maybe one of the other space colonies. The third challenge is the identification of resources. Before we send the robots to mine the surface of a planet or asteroid, we need to actually know what we are mining. By doing this, we can also find where the most resource-rich areas are, which we can use to increase the amount that we can mine. However, to do this, we need to develop the technology that can spot specific materials and predict how much of it is there. To a large extent, we do have the technology, but not to the degree that we need it for a large-scale space mining operation. As you can see by these images, we have been able to identify, for example, what materials are on the moon, but the technology isn't advanced enough yet to, for example, see what's under that material, close to the core or inside of caves. So whether it's going to be sending robots to explore these planets or celestial bodies or some kind of crazy camera technology, I'm not really sure, but we're going to have to develop it to ensure us that that place is worth mining. Another thing that we have to develop is the space infrastructure. As I mentioned before, water will be the main propellant in space because it's fairly abundant on asteroids and some planets in the form of ice, and it's very effective at propulsion. And so we need to build kind of like space gas stations, which will provide water to the mining robots, space tourists, and all the rest we may get up to in space. But this will be critical because without the mining robots having water to be able to move, they obviously can't go from one asteroid to another, so they won't be able to do their job. What I'm trying to get at is we need a lot of these water stations, as well as ways for the robots themselves to be able to extract water from materials. Also, once resources are extracted, for them to be any use for us, we need to get them back to Earth or anywhere else where humans will be. And this causes a number of challenges. We will need to develop more powerful and efficient propulsion systems, new cargo spacecraft, and docking mechanisms, just to name a few. Also, we need a way to actually get the space resources onto the Earth's surface, which will mean either very strong parachutes or landable rockets like the ones by SpaceX. For the most part though, we need these for human exploration anyway, so these challenges are already being worked on. As you can tell, I'm giving you very generic ideas of what we need to develop. This is because I don't have a crystal ball, so I don't know exactly the technologies that we will have to develop. Ultimately, innovation and investment in space is what we need to beat these challenges. This will be expensive for us in the short term, especially as for a large part, this research is funded by the government, but I think in the long run, it's probably the best investment a government can make. Speaking of the government, they will play a massive role in the space mining game, not necessarily because they will mine themselves, but because they are the ones who will create the rules for space miners.
Laws and regulations.
While the laws may sound like a much more boring subject compared to the tech side of space mining, it is actually a very interesting topic. In fact, it's very controversial, especially surrounding who owns what. Why should one nation or company or individual have the right to mine a particular asteroid, while another one can't? It's these types of questions that honestly, I don't know how to answer. It's one of those things where we will have to see what happens. However, as it stands today, there are some treaties and agreements that we can sort of go by. One is the Outer Space Treaty, which lays out the basic rules when it comes to space exploration. The key things that it says is that space is free for exploration and use by all countries. Outer space should be used to benefit all countries, and no nation can claim sovereignty over a celestial body. Now, while none of them specifically prohibit space mining, the fact that no one can claim ownership over a celestial body may be a bit complicated, because if a new extremely valuable asteroid was to be discovered, say 16 Psyche, everyone would mine that asteroid, which could cause conflict between the different miners, which could end very badly. I'm talking about wars in space. A similar agreement to this is the Moon Agreement, which states that the Moon's resources are a quote-unquote common heritage of mankind. This could be a very difficult agreement to get around, especially for private companies who want to mine the moon for, say, helium-3, because it suggests that the moon's resources cannot be owned by a single person, and so cannot really be sold. Also, not many nations have signed up to this, so would that mean that the companies from those countries have to abide by those rules while everyone doesn't? Also, how would these rules be enforced? Will there be some kind of space police? Look, I just gave you a bunch of questions. You may know the answers, you may have some interesting ideas about them. All in all, it's a very interesting topic, and if you're trying to get into law or economics or anything like that, I would say this is a very interesting sector you could get into. As I said, we all just have to see how this goes. But yeah, the laws will be a big part of space mining. From my perspective, I think that the laws that will be put in place will mostly be about promoting private companies to mine in space by ensuring that the supply of space resources is limited in order not to flood the market. In other words, allowing everyone who wants to mine in space, but making it economically responsible. Hopefully now you understand why space mining is a world-changing industry and the challenges, both technical and societal, we need to beat to become space miners. That just sounds really weird.